Okay, so now that we have what points are located in the US, we want to take a look and see what are the temperatures and precipitation levels that those have. And so in this particular case, we can't do that. There's nothing in our Wisteria data set that lets us do that. But we do have the county temperature and precipitation data set that is there. And so this is where select by location becomes very useful. So up at the top, if you're in the map ribbon, you can see that we also have the select by location. So this lets us take one layer and use topology to select things in another layer. So you'll notice that we still have these Wisteria points with selection on them. So we're going to hit select by location. Now, immediately it's going to try and put the Wisteria count table in here. That's not what we want. So in our input features, we're going to put what we want out of this. So we want to know what counties the Wisteria are in. And so in this case, I'm going to switch this out to county temperature and precipitation. That's that polygon file here. And then I'm going to take a look at what this relationship is. So which of these polygons contain our GBIF Wisteria. Now, when I put this in here, you'll notice that there are selected records, and it says use only those selected records. This is something that we want. So we only want to select the ones that are in the US, and therefore we're going to do that. And so then we're going to hit apply in this case. So you'll notice that there's some things that have become a little bit brighter. So if I zoom into any of these places, you'll see that now we have those points, but now we have those polygons, those counties that are selected. So now we have all of the counties where there's a Wisteria point that has been found. So we can right click on our county layer and we can take a look and see where those things are. So in this case, we have 108 different counties where those exist. So we're then going to take a look and we want to know what those counties are, right? So we have all of these different counties and we have our temperature, we have our precipitation, we have what state they're in, all of that information. So we have these 108 ones. Now, the other thing that we can take a look at, and we took a look at this when we did projections, is we can take a look at the statistics attached to them, which is what we want. So in this case, we want to take a look and see what is the maximum temperature, the minimum temperature, the maximum precipitation, the minimum precipitation, and the averages of those. So to do that, you're going to take a look at the century one, and you're going to right click on that one, and you're going to go to visualize statistics. This is where you have all of those statistics from before. So you'll notice it pops up with this nice histogram. And so in here, you can see that there's a data set one. This is the full data set. And then there's this selection one. So this is the ones, that selection point is those 108 ones, the ones that actually have Wisteria in them. And so that's where you're going to want to take a look. You're going to want to take a look at what is the minimum temperature, what is the maximum temperature, and what is the average temperature when you are just in those selected counties. And you're going to repeat that process for precipitation. The reason you want to do that is because then we can put limits into the counties and see where else has those conditions. This is going to let us see which counties may also have Wisteria even if there's not a point found there. So we're going to take a look. So you're going to want to write down what your minimum and maximums are in this case. So in my case, I've got a minimum of 57 for temperature. I've got a maximum of 82.9, and I've got a mean of 75.5. I'm going to let you do the precipitation one, but you're going to run it the exact same way. Find the precipitation century, right click on it, go from there. So, but now what we want to do is we don't want to see just where those ones that have Wisteria are. We want to see all of the ones that could have Wisteria. So after you have the minimum and maximums, what you're going to do is you're going to go back and you're going to select by attributes in the county one again. And you're going to do it based on the precipitation and the temperature. So we're going to head over, in this case, to the select by attributes in here. And we're going to say, I want to know where, in my case, temperature, the 100 years of temperature, is greater than our minimum. So it's greater than or equal to, in this case, I had 57. And, so it has to be greater than 57, and it has to be less than or equal to my maximum number, which was 82.9. From there, you're going to add another one with your precipitation, century 1, which is greater than or equal to your minimum, and then is also less than or equal to your maximum. Once you have all of that filled in, you'll hit OK on this, and that's going to give you a new selection of polygons of counties where that is. And those ones are the ones that have, based on our current set of data, the conditions where Wisteria could live. So once you have that full set of new selections, you're going to want to right click on it. You're going to want to go to data, and you're going to want to export those features. Right, so those ones, it will be more than 108, but you're going to say those ones are the potential Wisteria counties, and you're going to create this layer that will also just have that smaller section of things. So if I clear all of my selections, I turn off my Wisteria, then this one is just the 108, but you'll have more than this, but it'll only have that subset of things. Once you're done with that, you're going to want to go over to your insert, new layout. You're going to want to create your new layout, right? Create a map showing that potential Wisteria, and make sure you fill out all of the things in the report, and you should be good to go. So that's all we got, and I hope you have a good rest of the day.